to solve a work problem, we have people who can perform a certain job in some number of hours, and in this problem we have the length of time each person takes, and we want to find out how long it would take if they all work together. Now, this problem is a little bit different because we have the length of time it takes one person and then how long they can work together, and we have to find out how long it would take the other person alone. So let's look at what we do for the people working together. I'm going to make a chart with each person's name at the top, and also together. And together should always go on the right hand side, even if we know how long that takes for them to work together. I'll have two rows here. The first one is going to be the time to do the job. And for Isaac, we know that it'll take Isaac 3 hours. And Emily will take 5 hours. Nikki will take 6 hours. And we don't know how long it's going to take them if they work together. That's what we have to find out. So that one will be our variable. I'll use an X. Then my next row should be the amount of the job done in 1 hour. Since I'm using hours, I'll carry that over here to the amount of the job that's done in an hour. And if it takes me 3 hours to complete a job, in 1 hour the job would be 1/3 of the way finished. And if it takes me 5 hours to complete the job, then I'll have 1/5 of the job done in 1 hour. If it takes me 6 hours, 1/6, and if I don't know how long it takes me, it'll take 1/x, whatever that x happens to be. Now, since these three children are working together, we will add up their rates, and it'll be 1/3 plus 1/5 plus 1/6, and that's how much is done in an hour. We want to find out how much will be done in an hour with them working all together. Now, you might want to add these time to do the job hours and set it equal to the x, but if you did that, then you would have 14 equals x, and that it would take them 14 hours to complete the job working together. And we know our fastest person takes 3 hours. It doesn't even make sense for it to take 14 hours. So we have to do something different, and that's why we come up with how much of the job is done in 1 hour and use those ratios together to find our together time. So here I have a rational expression, and I need to find a least common denominator. And I know 3 goes into 6, so I can ignore it for finding the common denominator and just think about 5 and 6. And I know when I multiply the two I get 30. And I don't think that there are any multiples that are smaller that both of these numbers go into. So my LCD would have to have a 30, and then I also look at the variable. I'll need to have that on the LCD as well. And 3 goes into 30, yes. 5 goes into 30, yes. 6 goes into 30, and then the x is represented there also. So if my common denominator is 30x, and I have an equal sign, remember that's very important, then I can multiply both sides by that 30x. And on the right hand side there's just the one term, so I end up just with an equals 30. And for the left hand side, I do need to distribute for each term. They should each get their own 30x. So I'm going to just write it in so that it's easier for me to reduce. The 3 goes into 30 10 times, so I have 10x for my first term. 5 goes into 30 6 times, so I have 6x for my second term. And 6 goes into 30 5 times, so I have a 5x for my third term. So I've cleared my fractions, they're gone completely, and now I have three terms with the same variable x. I can add them up, they're like terms, and I have 16 plus 5 is 21, x equals 30. And I want the x by itself so that I know how long it takes them together. So I divide both sides by 21. And I have x equals, I can see this is divisible by 3. And this is divisible by 3. And if I convert 10 over 7 into a mixed number, it's 1 3/7. So together it takes them 1 3/7 hours. I mentioned that this problem was a little bit different because we knew how long it took one person and we knew how long it took them working together, but we didn't know how long it took the other person. And I want to talk to you a little bit more about how this is written. All the houses in Charlie's neighborhood are the same size. Now it's telling us that so that we know that the one job is about as big as another job, so that we don't think, well, Charlie took 20 hours and then they worked together on Don's house, but maybe Don's house is a little bit smaller. No, they're saying all the houses are the same size, so it's the same size job every time. And sometimes they'll tell you how long the fence is that they're working on, or how big of a job they're doing, so that you can see that every piece of the job is the same. Now, to start with, all the houses in Charlie's neighborhood are the same size. Charlie takes 20 hours to paint his house, so we know Charlie. And it's going to take him 20 hours alone. And that means that in an hour he has finished 1/20 of his house. And then we have Don. And even though we don't know how long it took him, we'll put him next because we always want to put together time all the way to the right, because it's always going to be on the equal side like we have up here on this problem. So Don, we don't know how long it took him, and in an hour he'll have 1 over however long it does take him completed. And then together, Charlie and his neighbor Don paint Don's house in 12 hours. So together it takes them 12 hours, and that means in 1 hour they have 1/12 of the job completed. Then the question is, how long would it take Don to paint another neighbor's house, which would be the same size job? And so we really want to know, how long does it take Don all by himself? So if we know our ratios for each of the three, we can set up Charlie plus Don equals the together time. And then we need to find a common denominator for all three of these. And I know my least common denominator is going to have an x in there. And then I'm going to look at the 20, and it's 10 times 2, which is 5 times 2. And I'm going to look at the 12, which is 3 times 4 and 2 times 2. So I'll take all of the factors, the prime factors for one denominator. So it's 5 times 2 times 2. And then I need 2 2's, and I already have 2 2's, so I'll share those, and I need a 3. There's no 3 showing, so I need to put a 3 on there. And that helps me find a common denominator. So then I have 5 times 2 is 10, times 2 is 20, times 3 is 60. So my LCD is 60x. And remember, I want to multiply both sides by that 60x. And on the right hand side, I'm just multiplying. On the left hand side, I need to distribute to the two terms I have there, which means that each term is going to get a 60x multiplied by it. And then I can reduce. So 12 goes into 60 5 times. X and x reduce. 20 goes into 60 3 times. Now my equation is 3x. And my second term is just a 60. And I have an equals, and then just a 5x on the right hand side. If I rewrite, I want to solve for x, so I'll subtract 3x from both sides, and I get 60 equals 2x. Divide both sides by 2.